The moisture content of wood is usually expressed as a percentage. This simply represents the weight of the water contained in the piece compared with the weight of the woody substance itself. To work out the percentage mathematically, you simply divide the weight of the water by the weight of the woody substance, and then multiply the answer by 100. The fraction part of the formula gives you the proportion of water to wood fibre, and multiplying it by 100 converts the fraction into a percentage. Here's an example of how to apply the formula. Let's say that this piece of softwood weighs 12 grams in its green state. Remember that green means the piece still contains a high level of moisture from the growing tree, because it hasn't had a chance to dry out yet. Now let's say that the woody substance in the piece weighs 8 grams. That is bone-dry woody material with no moisture at all. What's the moisture content of the piece? MC as a percentage is 12 minus 8 over 8 times 100, which equals 4 over 8 times 100, which equals a half times 100, which equals 50%. In other words, the water in the piece weighs half as much as the wood fibres themselves. The amount of moisture that a piece of wood can hold depends on its density, or the amount of solid wood fibre packed into a given volume. For example, balsa is a very lightweight, porous timber which can hold up to 4 times its own weight in water. That is, in the growing tree, it can have a moisture content of up to 400%. On the other hand, ironbark has so much woody tissue with thick cell walls that there's very little space left to hold water. Its green MC can be as low as 40%. There are 2 main ways of physically measuring moisture content in timber. The simplest and most efficient method is to use a moisture meter. Moisture meters work by passing a current between 2 probes pushed into the wood and measuring the electrical resistance between them. The principle is that dry wood is a good insulator and water is a good conductor. So the more moisture there is in the piece, the less resistance there will be to the electric current. However, there are some factors that can make this reading inaccurate. These include the air temperature at the time, the species of timber being measured, and the presence of any chemicals such as preservative treatments. You can improve the accuracy of the readings by looking up conversion tables which make corrections for these variables. But you need to remember that the result is only ever an approximation, probably within plus or minus 2%. A more accurate process is the oven dry method. This technique is used by kiln operators and other people who need to be precise in their measurements. The first step is to cut a small test piece from the timber, then weigh the test piece on a set of scales. This will give you the total weight of the woody material and water combined. Put the test piece in an oven at just over 100 degrees Celsius until all of the moisture has evaporated out of the cell cavities and walls. Once the test piece has reached a moisture content of 0, weigh it again to find out what the woody material weighs without any water in it. Then use the normal formula to calculate the moisture content of the original piece of timber. Although this time our formula will use the term oven dry weight to refer to the woody substance without any moisture in it.